and today I'm bringing Circle Theorem for you. And in today's lesson, by the end of this lesson, we are going to be going through the definition and introduction to Circle Theorem or circles, then division of some basic terms you need for Circle Theorem. We are going to look at the explanation and interpretation of those theorems, because without being, well understood of those theories, you cannot get to the point of solution to past question, because this one is application to the theories. If you are ready, please don't forget to hit the subscribe button, share this video, like it, and comment. So let's start with the first one, introduction. In my introduction, I'm going to first write a circle. This is a circle. What makes it a circle is not the shape. It is the condition that makes it a circle. What makes a circle is that at this point O, mathematicians usually use O to represent the center of the circle. At this point O, that the line from the point to any part of the circumference is the same. That is the condition that makes a circle. At this point 0, the line from here, from O to let's say point A, point B, point C, and point D, that line is the same. So if this place is 10 cm, this place will be 10 cm, this will be 10 cm, this will be 10 cm. So because the line from the center of the circle to any part of the circumference is the same, we now conclude that it is a circle. In a circle, we are going to have different terms used for defining a circle. Let me start it here. I'm going to say number 1 is going to be a radius. Every circle has a radius. And what is the radius? The radius is the line from the center to any point of the circumference, and it is constant. That is the radius. Another one we can also have, which is called the circumference. And what is the circumference? Circumference is defined as the this curved part that forms a circle. That curve must be closed, must be enclosed to form a circle. A circle is the shape which is formed when a circumference is formed. Through a circumference. We can also say that number 3 thing we must talk about. So, another thing, I'm talking about the definition of terms. We have talked about radius, circumference. Let's talk about the other one, which is called an arc. Because an arc is also used. So, an arc is also used to define a circle. So, what is an arc? An arc is just a part of the circumference. So, if from A go this way and comes back to A, is the circumference. An arc may be maybe from A to B. It's just a part of the circumference. So that is the meaning of an arc, a part of the circumference. Number 4 thing we must use to define a circle, we may call a sector. A sector is just a shape formed by 2 radii. Instead of radius, we have what we call radii. Radii means the plural of a radius. So when we have 2 radius, when 2 radii formed with an arc, we say that a sector is formed. For example, if I have from center O, from O, D, all the way to A and comes back to O, we say that a sector is formed. And look at the shape of the sector. Yeah, let's say A, B, and this is O. This is a sector. So that is why in government we talk about the agricultural sector, the educational sector, the judicial sector, the political sector, the economic sector. These are different sectors formed inside a whole of a circle. A circle may be a community, a country, or whatever it is. So that is a sector. From there we have another name which we call, number 5, I'm going to call a chord. Please, let's be taking it one after the other. A chord. What is this chord? If you have a circle, and this is the center of the circle O. If you draw a line, any line from here to here, let's say from A to B, we say that you have formed a chord. So what is a chord? A chord is simply a line joining two parts, two opposite sides of a circumference without passing through the center. Two sides of the circumference without 2 points on opposite side of the circumference without passing through the center. We can also have another chord. Another chord can be in this format. Let me draw it here and have a circle, and this is the center. Then from this part of the circumference to the opposite side part of the circumference, and when you join these 2 points, you say, let's say P and Q. You also form a chord. It can be this way, 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 without passing through the center. Whenever a chord passes through the center, a name is now called a diameter. So this is why I'm going to say number 6 is going to be a diameter. So what is a diameter? If I make any point, and here 2 points. So these 2 opposite sides of the circumference, right? And the line is drawn passing through the center. Once the line passes through the center of the circle, we call it what? Diameter. And diameter simply means what? 2r. That's the radius plus 2. Because from the center of the circle to the circumference is radius. From this center of the circle to this circumference is also radius. So radius plus radius is going to be 2 radius, which is equal to the diameter. Alright? So that is that. Let's keep going. I am sure I'm not going to forget anyone. So let's go to the next one, which is called segment. What is a segment? Let me use this part. Let me use this circle to explain what a segment is. You know, a segment is a region, and this is number 7. A segment is a region, a shape formed when a chord and an arc are formed together. Remember when I mentioned a sector, I said a sector is a radius, 2 radii, and an arc forms a sector. But when we talk about a segment, we're talking about when a chord and an arc, for example, PQ is a chord, and from Q to P is an arc. So this part, which I'm shading right now, is called a segment. But in this segment, we have bigger segment and smaller segment. When we talk about the bigger segment, we are talking about my major segment, right? And then the smaller part, which is going to be called the minor segment, right? So, is there any other one? Is there any other one? So, most of the things we are going to be saying in the theory, we are going to be using these terms to explain this theorem. So, you need to understand what these theorems are, how they are used, before you'll be able to come to the interpretation, understanding of those theorems. Please, I don't know if there is anyone I'm forgetting, please remind me on the comment section as we keep moving, okay? All right, that is it, that is it. Let's go back to the next one, which is called the explanation and interpretation of those theorems. Let's continue from where we stopped, all right? Remember, we're still on the definition. We've not started this one, so let's keep going. I want to give you the full video on everything about circle. So let's go. Now, in this part too, which is still on this part, you know, I'm saying the area of a circle is 81 pi cm squared. Find the diameter of the circle. Alright. So we have number 1, number 2, number 3, number 4. After this, we bring other kinds of calculation on circle for you to understand these terms very well before we go into other theories. Alright. In this one, I'm going to be solving them here. So let's go to number 1. The area of a circle. Whenever you see the area of a circle, look at area of a circle. Let me say area sub C is given as pi r squared. Alright. But area of the circle is already given as 81 pi cm squared. Alright. Therefore, this must be equal to this. So I'm going to say that 81 pi, which is equal to pi r squared. Pi will cancel pi, right? We say that r is equal to plus or minus square root of 81. Because of these two, it will go and become a square root. So r is equal to what? Plus or minus 9. So which is simply plus 9. Don't mind me. plus 9 is the radius of the circle, but we are looking for the diameter. Remember what I said, diameter is what? Can you tell me? Diameter is 2 times the radius. Therefore, diameter is going to be 2 times 9, which is what? 2 times 9 is going to be 18 cm. All right, that's the answer for number 1. That was very simple. Number 2, calculate the circumference of a circle, center O, and the radius is 3.5. So, number 2, we are looking for the circumference. Circumference of a circle is given as C is equal to 2 pi r. This is circumference of a circle, and we are given radius to be 3.5. So pi must be there as 22/7. So circumference is going to be 2 times, in place of r, I'm going to say 22/7 times. Radius is 3.5. Remember, 3.5 is something as 35/10. Converting decimal to fraction. So 5 into this is going to be 7. 5 into this is going to be 2. Yeah. So I'm going to say that this is equal to 2 times 22/7 times 7/2. Right? 7 cancels 7. 2 cancels 2. The circumference of the circle is 22 cm. Remember, the circumference is a distance or is length. So you should have in cm. The unit must be there. You must always put the units. Okay? So we have another one. This is a very technical question, and we are going to handle it easy. We are going to handle it very carefully. All right? So let's go to number 3. All right, the number 3 question there. They now say that the minute hand of a wall clock, so this is the wall clock, right? The minute hand, let's say this is the minute hand, and this is the hour hand, but remember the one, the second hand. So this is the minute hand, right? He said the minute hand of a clock is 9.7. Don't mind that. The minute hand must start from the center of the circle to touch the circumference. Therefore, it means that the radius is equal to 9.5, which is in cm, and that is the minute hand. All right? I say it's 9.5 cm long. So what distance does it cover? Does its tip cover in 72 hours? These people are very careful. And please, this is GCE question. November. All right, they are very smart. They need to tell us that it is actually the tip, not this part. That's very, very technical to say. I love the question. All right, what distance does it cover in 72 hours? Well, you need to know that for this, if this place is 12, for this minute hand to go, this is clockwise. For it to go from here all back to this hand is going to be, sorry for that, is going to be 1 minute, is going to be is going to be times 60, which is going to give you what? 1 hour. So 1 minute hand is going to go the full circle, which is going to give you 1 hour. Right? So let me put it better. 360 degrees for a minute hand is going to be 1 hour. All right. So if 1 hour is what the minute hand takes to go 1 complete circle. Now remember that 1 complete circle gives you what? 1 circumference, or gives you a circumference. Therefore, 1 complete circle is going to take what? 2 pi r. That is 1 hour in 2 pi r. So 72 hours is going to be 72 of these circles. Therefore, the total distance, so distance covered is going to be 72 times 2 pi r. And 72 times 2 times 22/7 times r is going to be 9.5. Right? So let me just use this to. So this is going to be 72 times 2 times 2 times 9.5 divided by 7 So this is going to be 4299.43 cm. Alright, this is the distance it has covered for 72 hours. Sorry, the question I struggled a little on that question, but I think that is very correct. So the last one, which is IV. Alright, let's solve it here. He said x and y are circles such that the radius of x is twice the radius of y. If the radius of y is this, find in terms of pi the area. Alright, fine. I'm going to have area, and this is not hard actually. The area of x is going to give you pi r squared. Okay? And then the area of y is going to give me pi r squared. So, but then this r is going to be sub x, and this is going to be sub y. That means the area of x and the radius of x, because that is the only thing that differentiates the two circles. But pi is constant. Now, having that, but it says that such that the radius of x is 2 times the radius of y. That means the radius of x is 2 times the radius of y. That means wherever I see the radius of x, I'm going to put the radius of y to be this. Or wherever I see the radius of y, I'm going to put 1 over the radius. Radius of x divided by 2. Now, what else did they say? If the radius of x of y is 5, so the radius of y is 5, therefore the radius of x is going to be what? 2 times. The radius of 5 is already, the radius of y is already given as 5. So it's going to be 2 times 5, which is going to be what? 10 cm. So what I'm looking for is said, find in terms of pi the radius of x. Alright. Okay, so I will say that the radius of x is given as pi 2ry all squared. So this is going, area of x is going to be equal to pi bracket 2 times ry. 2 times ry is what? 10 squared. Therefore, the area of x is going to be what? 100 pi cm squared. So that will continue. The next thing I'm going to bring is more questions on the definition of terms before we go into this particular one. So we are going to be talking about area and perimeter of a sector, perimeter of a circle, perimeter of a segment, length of an arc, and other something. Please don't forget to hit the subscribe button, like this video, and comment. Tell me. I want to hear what you have to say. Let's talk about the length of an arc, area of a sector, perimeter of a sector, length of a chord, area of a chord, and perimeter of a chord. We are still on number 2. We've not even done number 3, and we've not even done number 4. So don't be too fast. Let's take it one after the other so that we become complete or very close to complete in circle. Let's talk about length of an arc. So if this is a circle and this is the center of the circle, how do we form an arc? You can remind me. Who can remind me? How do we form an arc? An arc is formed when you draw a radius and at a point on the circumference to make point A, and probably draw another one at this point to make point B. You have made an arc. What is the arc? The arc is from A to B, the length from A to B. But then there are 2 kinds of arcs here. The one is smaller arc and the one that is bigger arc. We call them minor arc and major arc. I didn't mention that in the first place, but that is what it is. Okay, so in this part right now, we want to find what is the length of AB. Length of AB. It is always given as the whole of the circle is what? Remember, this arc must make an angle theta. So you see, let's just come to this part. If this is just a whole of the circle, a fraction of the circle was given to this arc. a whole of the circumference. A part of the circumference or fraction of the circumference is given as AB for this side of it. So what we are going to do is to convert this angle that was made, because the whole of the angle is 360 degrees. We're going to convert this angle to the full circumference. And remember, conversion is basically multiplication. Now look at what I'm going to do. I'm going to say that part of that the 360 degree, because the whole circle is 360 degrees, part of it, which is called this part, all over 360, multiply it by the whole of the circumference, which is 2 pi r. So this gives you the length of an arc. So area of a sector. Area is the same thing, area of a sector, right? The area of the sector is the same thing. The whole of the circle has an area which is pi r squared. But a fraction of it was taken out by this angle. It is the angle that formed the area of the sector. So that area, we are going to say this angle all over the 360 converted to the area of the circle. So we are going to have theta over 360 times pi r squared. This is the area of the sector. Then when we talk about the perimeter of the sector, perimeter simply means addition of length addition of parts or lengths that form that particular shape. Now, a sector is made up of OA, OB, and AB. So the perimeter at this point is going to be OA is same thing as R, then OB is same thing as R. So therefore I'm going to have R plus R, then plus from A to B. And what is A to B is the length of an arc. So plus theta all over 360 times 2 pi r. So simply put 2r plus theta over 360 times 2 pi r. 360 degrees, remember. So this is the perimeter of a sector. Whenever you see a sector, this is the formula for perimeter. Let's talk about the length of a chord. Alright, when it comes to a chord, let's use this circle. This is the center O, and the chord is from here to here. So call it point A and point B. So at this point, right now, how do I find the length of AB? There is a theorem I'm going to let us know when we get to number 3, but I cannot do this without that theorem. Because there is no, for now, mathematically, I don't think there is any way I can just find this length without this analysis. There is a law that says that a line from the center of the circle meets a chord at angle 90 degrees. That means a line from the center of a circle divides the chord into 2 equal parts and meets the chord at angle 90 degrees. That means if I call this place N, AN must be the same thing as NB. So if from here to here is 10 cm, then from here to here is also going to be 10 cm. Because they say that that line that comes from the center of the circle will divide any chord it sees into 2 equal parts. And then will also meet that particular chord at angle 90 degrees. So for this reason, I am going to make this radius, because radius is there and there is an angle it has formed. I'm also going to, yes, let me call that angle theta, right? Because once I find NB, I have found AN, then I will add them together. All right, so let's go here. In this case, I'm going to say, I'm going to have sine of that theta is equal to opposite, which is NB, like NB all over opposite over hypotenuse, which is R. Therefore, NB is equal to R sine theta. All right, so therefore, the length of the chord AB is equal to 2, no, is equal to, yes, 2r sine theta. There is something people usually do. Remember, okay, I think I have to obey that because remember when I made AB, I gave it a whole of the theta. So when I divide this side in two places, this theta is not going to be a full theta, it's going to be theta over 2, and this theta over 2, which gives you the full theta. So for the sake of uniformity and what other textbooks are doing, I will say that from here also to this place is going to be theta over 2 and theta over 2, so that I will have a rho theta there. But whatever it means, any angle you give here, applying this my principle, you will still get your answer. So let me put it sine over 2 over 2 over 2, just for the uniformity with other textbooks. Remember what I'm doing is proof, and it is true for any of this chord for now, since mathematicians have not changed it. Alright, so this is the length of the chord. What else am I looking for? The area of a chord. Oh, that is really going to talk about shaded portion. Should I do that right now? Should I do that right? Okay, fine. This is the chord. Remember, the chord in this case is going to be from this part. This is the chord. Remember, I told you a chord is not chord segment, please. I'm talking about the area of the chord. No, shouldn't be the area of the chord. It should be area of the segment. So area of the segment. See the segment A, B. All this shaded is the area of the segment. And I think I will just give you the answer for that. When I will be talking about shaded portion, I'll explain it later because the principle came from that of the shaded portion. But let me try. Area of segment. This way. I wanted to look at. The truth is, it will still work. It still give me the answer because I do some crazy stuff. But then I'm not going to look at the whole of the circle. Remember what I'm looking for is this shape to this side. So I'm going to say area of the whole sector because everything from here to here is a sector minus area of the triangle. So that's what I'm going to say. I'm going to say theta over 360. So this is times pi r squared. This is area of the sector. The sector is A, O, B, including this arc. That is the area of the sector. Then minus the area of this triangle. Then and the area of the triangle is going to be half r squared sine theta. Half r squared sine theta. Half of the remember the theta I'm talking about it. Both this angle and this angle, they are the full theta. So r squared, remember this place is also r squared, half of the r squared sine theta is going to be the area of this triangle here, and the whole of the sector is theta over 360 times 2 pi r. So with this, you can always get the area of this segment. Alright, so let's talk about perimeter of a chord. Perimeter of a chord. No, it can't be perimeter of a chord, it's still the perimeter of a segment. So perimeter of a segment, perimeter of this segment is going to be, the perimeter is going to be A, B, plus the length of this arc. So what is the perimeter? Perimeter of the segment, remember, is going to be AB, length of AB is going to be 2r sine theta over 2 plus, because that is the length of AB, then plus the arc AB, and that is going to be theta over 360 times 2 pi r. So this formula can give you the perimeter of the segment. All right. With this understanding, we are going to solve other questions that explains how these things can be applied in problem solving. After this, we can now talk about explanation and interpretation of theorems. Let's continue on this part, but we have this question. We are still targeting this and this so that by the time we'll be talking about interpretation, it will be easier for you. Alright, we have that in the diagram, this is the diagram below, which is a circle, is stated is a circle. O is the center, O is the center here. PQ, from P to Q, is a chord where OQ, where OQ is 15 cm, that should be the radius, not that should be, that is the radius. QR, no, it can't be QR, it should be OR. OR is 6. OR is 6. So it says calculate the length of the chord 1 decimal place to the nearest 1 decimal place. The angle subtended by POQ. This is POQ, alright? And the perimeter of the minor segment. In this case, we do not know which one is the minor segment, but let's get on with it. Alright, the length of the chord. Alright, that means from here to here. I can't find the length of the chord unless I find the angle here. So first of all, length of chord, which is PQ. Alright, so remember I have to put this on the 90. So let's find this. This is going to be OQ squared is going to be equal to RO squared plus RQ squared, right? So this is going to be 15 squared is equal to RO, which is 6 squared plus RQ squared. So this is going to be RQ squared is going to be equal to 15 squared minus 6 squared. So this is going to be RQ is equal to simplify this, I'm going to say, okay, let's say 2 to 5. 15 squared is 2 to 5. 2 to 5 minus 36, which is 189. And square root of 189 is going to be 13. Square root of 189. No, not 13. It's not 169. 189. Square root of 189 is going to be 13.748 cm. Now remember the length of the arc, which is PQ. The length of the arc, which is PQ, is going to be 2 times because we found only from R to Q. So to get from P to Q is going to be whatever I get here times 2. So the length of the chord PQ, which is the first solution, is going to be 2 times 13.748, which is going to be times 2, which is going to be 27.5. Remember they said we should go into the 1 decimal place. I didn't do 1 decimal place here until I finish, until I get to the final answer. If I had said 13.7 here, times it by 2, you will have a different answer. So 13.7 times 2, you have a different answer. So the best thing is open all of them to at least 3 decimal places or 4 decimal places. Then the final answer is where you are going to do the round off to 1 decimal place. Alright, so this is going to be 27.5 cm. That is the length of the chord from P to Q. Alright, the next one they say is the angle subtended by POR. POR, that means from here to this to this. So what I will do is I will get this angle times it by 2 to get me this angle. Okay, let me continue using this and this. Remember this place is already given as 13.7, right? Let's say 14 to the nearest decimal place, but leave it. I'm going to use this side and this side. So this is going to be theta. Whatever I get here, I'll multiply it by 2 to get here. So that is going to be cos. Theta is going to be 6 over 15 theta is going to be cos inverse of 6 over 15. Theta is going to be cos 0.4, cos inverse of 0.4. Theta is going to be cos inverse 0.4 is going to be 66 point, I think to one decimal place will also be fine, 66.4 degrees. Oh, since that is not the final answer, 16.422 degrees. So the angle POQ, yes, POQ is equal to 2 times 66.422, which is equal to, and that is going to be 2 times 66.422, which is going to be 132.8 degrees. So that is the angle from P to O, or from here to this place is going to be 132.8. All right, so the last one is perimeter of the minor segment. The question is, which one is the minor segment? Of course, this is actually the minor segment. You know why? Because the angle from here to here is the major segment, and that is going to be 360 minus 130, 132.8, which is going to be 227.2. So the bigger the angle, the bigger angle is called the major segment, while the smaller angle is called the minor. So what is that formula we were able to, we found out, okay, let's do it here. The formula for perimeter of a major segment, of a minor segment, is going to be, perimeter is going to be length, okay, length of the chord and length of an arc. Okay, length of the chord is going to be perimeter. Okay, so which is YII. Perimeter is what? The length of chord is 27.5. So I'm going to say 20. You have to write the formula, very important. So I'm going to say it's going to be 2R sine theta over 2 plus theta over 360 times 2R. So this is the formula for the perimeter of a segment. Let me. All right, so in this case, remember our theta is 132.8, but this one already has been found to be 27.5. So this is going to be 27.5 plus theta is 132.8. So this is 132.8 all over 360 degrees times 2 times 22 over 7 times. What is the radius? The radius is from the center to the circumference, and that is 15. So I'm going to say that 132.8 times 2 times 22 times 15 divided by 360 times 7 is 22. Okay, fine. Let's continue. Let me finish it here to avoid mistakes. 27.5 plus, this is going to be 87648. 1, 2, 3, 4, 5 divided by 360 times 7 should be 2520. 360 times 7, 2520 divided by 2520. So this is going to be 27.5 plus. So this is 87648 divided by 2520, and which is going to be 34.8. So this is equal to 7.5 plus 34.8, which is 62.3 cm. This is the perimeter of the minor segment here. All right, so I think at this point, other question you can bring, maybe I may solve one more question. Let's now go to the interpretation and explanation of the theorems. Please remember, you should always subscribe to this channel, comment, to state or say all those that if I have X and Y, the law says that a line from the center of the circle will do two things. A line from the center of the circle will meet the chord. When it meets the chord, two things will happen. Number one, it will meet the chord at angle 90 degrees. So let's assume it meets this chord at this point. So from the center of the circle, meeting the chord, it forms angle 90 degrees with the chord. Of course, if this side is 90 degrees, remember that this side must also be 90 degrees. Then what else? It divides this chord x, y into two equal parts. So I'm going to put these two signs. So that is the law. The law says that a line from the center of the circle divides the chord into two equal parts and meets the chord at angle 90 degrees. So these are the two things that this does. I don't know if we are going to solve questions from each of the laws. So you need to pay attention for the laws. And that simply means that if I have a circle and a line, which is the chord, if I'm given 12 cm of the chord, and I'm asked that a line from the chord is, let's say, 5 cm, I am asked to find the radius of the circle. All I'm going to do is, this is 90 degrees. This one being the radius is, I don't know. So that this place is going to be 6, this is going to be 6 cm. So what should I do? I will apply Pythagoras theorem. This is unknown, this is 5, and this is 6 cm. So in this case, what should we do? We are going to apply Pythagoras theorem. This is going to be r squared is equal to 5 squared plus 6 squared. R squared is going to be equal to 25 plus 36. So r squared is going to be equal to 1 is 561. R is going to be square root of 61 cm. Alright, so this is what gave birth to this kind of approach in math solving. Number two equal chords are equal distance from the center of the circle. That is law 2. Let me put it here. You know, if I have a center of the circle, and if I have a circle, and this is the center of the circle, if this chord is the same thing as this chord, that means they are equal in length. If, let's say, AB is 10 cm, and let's say XY is also 10 cm, it simply means that the line from the center of the circle, if it is 5 cm, then the line from this center of the circle will also reach this chord at 5 cm. We say that equal chords are equal distance from the center of the circle. Equal chords are equal distance from the center of the circle. Or sometimes they say equal chords are equidistant from the center of the circle. Equal chords are equidistant from the center of the circle. Number three, what should I put in this number 3? I think I'm done with the chord rules. Which other thing should I say about the chord? Right. No, let me put this. Let me say it. Let's assume we have a tangent. I know it's also part of the tangential law, but chord is part of it. No, it's not chord. All right. Let's leave that one. Okay. All right. I'm trying to say whether I should include it here or not, but let me go. Let me call that one alternate segment. Alternate segment. The law says that if you have a circle, right, and you have a tangent, this is a tangent. What is a tangent? A tangent is a line which touches the circle without passing through the circle. For example, this line here is tangential line. But once it enters inside, it has become a chord. So this is a tangential line. So if you have a tangential line which passes through one point and makes a point on a circle, then a chord is drawn from that point of contact with the tangent. Then you have a triangle inscribed in the circle, then it means that, remember, this is a chord and this is a chord, which forms a rectangle. Oh my God, not rectangle, which forms a triangle. The law says that the angle which this chord makes with this tangent is equal to the angle the two chords makes with each other. So this angle, theta, must be the same thing as this theta. We call it alternate segment. So if this place is 50 degree, this must be 50 degree. Why? Because this chord and this tangent makes an angle. So it forms an angle at the alternate segment. The same thing happens if this place is, let's say, 100 degree, this side will also be 100 degrees. So this is called alternate segment. I also want to bring another one that has to do with tangent and the line from the center of the circle. Let me call it number 4. If this is a circle, and then you have a tangent, and this is the center of the circle. A line from the center of the circle meets the tangent at angle 90 degrees. If this is the center of the circle, a line from the center of the circle meets the tangent at 90 degrees. So these are the 4 laws I have given us so far. Let me go to the other one, which is the number 5, and bring that one up. All right, let's look at this number 6 law. And I have to write it this way, though it's big. Remember, I'm going to interpret what it is. He said, the angle which an arc of a circle subtends at the center of the circle is twice that which is subtends at any given point on the remaining part of the circumference. All right, look at this. All right, so if this is the center of this circle, O, he said the angle which the arc, let me get an arc. Let me get this point A and get this point B. All right, this is an arc from A to B. The angle which this arc subtends at the center, this angle here, which is subtends at the center, let me assume it subtends 80 degrees at the center. He said is 2 times that which it subtends at any given point on the remaining part of the circumference. Remaining part of the circumference means from this part all the way to this part. So if this arc subtends 80, it's going to subtend 2 times. 2 times of what of 80 is going to be 160 on the remaining part of the circumference. So the remaining part is going to be, it could be point P, could be point Y, could be point Q, could be point M, could be point N. So all these, oh my God, that is the way I used to tell my students. Provided this arc, these angles M, N, N, M, Q, Y, P are coming from A and B, they must be 2 times the angle AB subtends at the center. So, oh, if I have a ruler, I need a ruler, okay, fine. I'm going to say, right? You see? So, AB has subtended another angle at this point. So, this angle is going to be 160 degrees because it is the remaining part of the circumference. So, let me assume this is another one. This is also going to be 160, right? So if you are coming from Y, if you are coming from Y, it's also going to be 160 degrees. If you are coming from Q, it's also going to be 160. If you are coming from M, it's also going to be 160 degrees. This is the rule. Because there are 2 sets to this arc. Look at this. From this AB to this side is on the same segment. Then from this AB, go this one is the minor segment. So The angles, they all subtend, provided all the points P, Y, Q, M, N, they are all putting their terminals or legs at A and B. They will be double of the one. Oh, it can't be double, sorry. Oh my God. Sorry. This should be 80, and this is going to be 40. Sorry, to be half, not double. 40. Oh my God. What wasted energy in explaining this. Thank God I found it now. So, sorry about that. I said the angle which an arc of a circle subtends at the center of a circle is 2 times which is subtended at any remaining. So, 2 times of this is going to be at the center, 2 times of this is this, provided they are all putting their legs at A and B. Sorry for the time wasted, please. I'm sorry. But let's continue. But because I've corrected it, of course, AB is going to be. That is the rule. And there is another one which is called, number 7, which is called angle on the same segment. Angles on the same segment are equal. That is this which I just explained. All these angles which are coming from the same segment and obeying these, they must be equal. Since the angle at P is coming from the same segment and they're coming from A and B, they must be equal with all other angles. We obey that given rule. This is what it is. Okay, so the next one we are going to look at is semicircle. If I have this circle and angle formed on the semicircle. Alright, so if I have a line drawn through the center of the circle, which is the diameter, and then with this, another angle is formed on the circumference. Coming from this diameter, we say that it forms angle 90 degrees. We call it angle of a semicircle is 90 degrees. So because A, B, and let's call this P. Because the angle here is 90 degrees, must be half of the one which is coming at this point, which is 180 degrees. So it's still obeying this principle, but in a different fashion. So for students to be able to understand that, we say that provided there is a line passing through the center of the circle, or let's say provided there is a diameter, the angle it forms on any remaining part of the circumference must be 90 degrees, which is even this part, even if the angle is coming from here, it's also going to be 90 degrees. This is angle on the semicircle, number 8. Number 9, let me go to number 9. Number 9, okay, let's talk about this. If I have a circle and we have, the name of the rule I want to explain is circle quadrilateral. So if you have a quadrilateral inside a circle, we say that the opposite angle are supplementary. That means if this angle is x and this angle is y, it means that x plus y must be equal to 180 degrees because there is 4-sided shape. Inside the circle, their opposite angle must be equal to 180. Even this side A and this is B, they must be A plus B must be equal to 180 degrees. We call it cyclic quadrilateral. Cyclic quadrilateral. Now, I have this question, and I'm going to apply the principle that says twice the angle of the circumference is angle of at the center. Because if you look at this question, this is a circle. Forget all these things they brought in here. So this is a circle, so I'm going to look at this as a circle. Now, for one reason why I am choosing that principle or rule is that from T entered P and entered S. I like to use that to humorously say it. I say that T has 2 legs. One leg entered the point P and the other leg entered point S. And the one at the center also has 2 legs. One leg entered at P and the other leg entered at S. For that reason, 2 times this one is going to be the one at the center. So I'm going to say 2 times 20 is going to be the one angle POS. S. Why is it so? Twice the angle at the circumference. For that reason, I'm going to say that POS is going to be 40 degrees. But that's not enough. It is this angle I found here that gave me the power, yeah, that gave me what I used to solve this one, because I'm looking for this angle. Now, this is an isosceles triangle because it said that OQ is equal to OR. So from O to Q is something as O to R. That has concluded the fact that it's an isosceles triangle. And every isosceles triangle, we have their base angles to be equal. So this angle and this angle are equal. So what am I going to say? I'm going to say that x plus x plus this place, remember this place we have found it to be 40. So it's going to be 2x plus 40 is equal to 180. Why did I do this? Why did I make this mathematical statement? Because the sum of angles in a triangle must be equal to 180. And I have to state it. I would say that sum of angles in a triangle. So in this case, I'm saying that x is equal to 140 divided by 2, which is what? 70 degrees. Therefore, angle OQR is 70 degrees. So that is that we have found this. Let's get to this one. I am sure this is not going to give us trouble, but I'm suspecting it may give us trouble. But the principles will be the key, and that will help us to solve. All right, so I'm going to say that the angle we are looking for, sorry, there were questions here. I am supposed to write those questions, but then we are asked to solve for y and for x. Remember what is x? X started from this line and stopped at this line. Therefore, I have this part and I have this part. They are all different. So I'm going to call it A and B. So also remember from here to here is different from here to here. So for y is starting from here and stopping here. All right, so in this case, I'm going to make a conclusion by saying that x is equal to A plus B. I'm keeping it as equation 1. Don't bother, that's how I do my maths. I like it easy. I like it easier. Okay, but then the Q has two legs. One leg entered at P, the other leg entered at T. Which other one did the same thing? R, this A, which is R entered at P and entered at T. Therefore, A is equal to 33 degrees. Why? Angles on the same segment. Angles on the same segment. That's the rule. Therefore, this is 33. All right, but then look at this. TOS. O has two legs. One leg entered at T, the other leg entered at S. But R, the other part of R, which is B, one leg entered at T, the other leg entered at S. Since R and O are putting their legs on the 2 points on the circumference, but it happens that the one R is on the circumference while this one is at the center. I'm going to invoke this law twice the angle at the circumference. So I'm going to say that 2 times B is equal to 76 degrees. Why? Twice the angle on the circumference equals angle on the center. All right, so that's going to be B is going to be 76 divided by 2. 76 divided by 2, 70 is 35, 33, which is 38 degrees. B is 38 degrees, so B is 38 degrees and A is 33. Therefore, X is going to be 33 plus 38, which is equal to this 11, put 1, 6 plus 1, 71 degrees. So I've gotten my X. Now I've gotten my X. Let me look for my Y. All right, it's going to be easier. I was thinking it's going to give me a hard time. But then this is going to be angle 90 degree. Why? Because TR is a line which passes through the center of the circle. So it subtends angle 90 degree at a circumference. Therefore, I'm going to say that 90 plus A, this is A, remember, A, 90 and Y, plus Y is equal to 180 degree. Why? Why is it that is sum of angles on in a triangle? So this is 90 plus A is what? 3 plus Y is equal to 180 degrees. This is 123 degrees plus Y is equal to 180 degrees. Am I right? Okay, Y is equal to 180 minus 123 degrees. Y is equal to, this is 757 degrees. So Y is 57 degrees. In that case, we are going to be able to find what is Y and what is Z. Ladies and gentlemen, this is where we draw the curtain on this episode. I'm going to solve many questions on Circle Theorem, but please don't forget to share this video, like, comment, and share it, subscribe. Have a nice time.